So let's see one example or problem. So it's the problem is related to the distillation of mixture of benzene and toluene. So we have a 450 pound mole. So we can say feed is given 450 pound mole per hour of a mixture of XF is about 0.6, 60 mole percent. So benzene LK. So it means you can see LK, the data I told you, all the graphs, all the calculation will be based on the light key components. So you can also see the data is also given for the light key component benzene. So it's benzene. So everything we are going to write here based on the light key component. And 40 more percent toluene. So forget about toluene. Is to be separated into a liquid distillate and a liquid bottom product. So liquid distillate and bottom. So XD is 0.95. First is liquid distillate, so it will be 9.95. Then liquid bottom 0.05. And it's written for benzene. So it means it's for sometimes it's written like 95% of toluene. It means 5% is for benzene. The feed enters the column with a molar percent vaporization. Molar percent vaporization means psi. So psi is equal to the feed enters the column is now the feed information with the molar percent vaporization equal to distillate to feed ratio. So it is equal to distillate to feed ratio. This is given from the problem. Okay, so it means the problem gives us clue how we can find the psi value. Otherwise, sometimes the psi value is given, sometimes the Q value is given, but there is no such question that your psi is equal to D over F. But this is only based on the problem that you can, it's given in the problem statement that the feed enters the column with the molar percent vaporization with psi equal to D over F equal to distillation. Use in Cape-Thiele method, compute at 1 atm. What first we need to find number of stages. B, we have to find R minimum. Okay. C, we have to find the number of stages. So actually I guess the first one is N minimum. So there is maybe not written. So first one is N minimum, second is R minimum, third is N at R over R minimum 1.3, and fourth is feed location. So we can also add the fifth, we can also add boil up ratio. If you like. So we can solve this problem. Hopefully it will give all solution for all these parameters. So I have multiple graphs, so I will show you. So the first step is, so anything else is given? No. So what we need to do is, first we need to plot the graph. So first step is, I told you already, plot the graph. So alpha is not given. Instead of alpha, x and y is given. It means, so the x and y is given, so we need to plot the graph. So here I already plotted for myself so that we can solve the problem quickly. So it's already done. You see the curve is up and down a little bit inside because the alpha is not smooth. That's why xy data is given. So, and second is we need to locate all these points. So we have 95% XD. So 100, this is 90, 95. So this is 95% XD. So this is your XD. Then we have feed is 60%. So this is your XF, this is your XD, this is your XB. So feed is 60%. So 0.6 means 60%. And bottom is 0.05. So XB. So our goal is, first goal is to locate all these points. So what we can do is, first we need to find n minimum. Okay, so we can do find n minimum. So this graph is used, we can use for the finding n minimum. So what we need to do is, I told you the rule. The rule is n minimum, actual n, and infinite. So n minimum when we have total flux. So I told you this line is total flux line. N is equal to R when we have actual n, and this is infinite number of stages when we have n R minimum. So what we need to do is, for finding, so this line is called total flux line, R x is equal to y line, R, this line is called 45-degree line. So this line has three names. So this is RT, means total flux. So what you need to do is, for n minimum, you just need to draw, no need to draw any line, just need to draw lines like that. First horizontal line until equilibrium curve, then draw vertical line until the XY line or 45-degree line. You have to repeat until you finish your until you reach XB. If you reach XB, just stop. Make sure you are drawing straight lines, okay? Don't use hand, use ruler. So you can see this is 1, 2, 3, 4, 5, 6. 6 are there, but the last one is fraction. So fraction is the distance from this point until this point. This is the XB vertical line, and the distance from XY 45-degree line until equilibrium line. So this is the equilibrium curve. So it looks like you have so there is a certain, actually you can measure the length. So total length is 5 centimeter, and the fraction is up to, so the fraction is, you can say fraction if you want to calculate. Fraction is the length from this point, you can give any name of this point, or you can from 45-degree line to XB vertical line divided by length from 45-degree line to equilibrium curve. So in my case, I got 3.5 up divided by 5 centimeter. So if you calculate this one, so it will be equal to 3.5 by 5.7. So around 0.7. So it means, so we got n minimum 6.7. So this is how easy is to get the minimum number of stages. We didn't do anything, no need to draw any rectifying line, no stripping line, no Q line. In case of n minimum, we just need to draw the stages. How we draw? We start from XT, horizontal line until equilibrium curve, then draw vertical line until the 45 degree, then horizontal, vertical, horizontal, vertical, horizontal, vertical, until you reach the XB. So if you must have to cross XB. Once you cross XB, then you have to calculate the fraction. So in my case, you see the fraction is 0.7. So ultimately you can write down this one as 7, because if you apply the significant rule. So this is for the part A. Now let's see part B. Part B is we have to find R minimum. So again, make sure you draw the line. It should pass through the all these intersections. Okay, this shows that you have 45-degree line, and it must be from 0 to 1 and from 0 to 1. So x-axis, y-axis, for only for the more volatile. Now what to do is, the second part is we need to find the R minimum. For finding R minimum, again step is same. You have to first locate XD. So we have XF and we have XB. In order to find R minimum, we need to find first the psi. We need Q line. For R minimum, we need Q line. So only information for Q line is psi is given. Psi is equal to D over F. So but it means we need D. So how we can get D? For D, we need to find, first apply overall balance on the distillation column. So remember, we have distillation column. So this is F. So this is D. This is B. So we can apply overall balance. Then we can apply component balance. So if we solve, so F is given 450. So this is 450. So this one is 0.6. This is 0.95. This is 0.05. So two unknowns, two questions. If we solve them, we can able to get. So D comes out to be 275 pound mole, and B comes out to be 175 pound more. So we can substitute this D over here. It comes out to be 275 divided by 450, and we got the answer about 0.61. So this is our psi value. So what will be the Q value? Q is equal to 1 minus psi. So 1 minus psi, it comes out to be 0.389. So this is Q. Now we need to plot the Q line. So Q line must be at the feed point. Must be at the feed point. So what is our Q line? So Q line is, we have one point here. In order to draw a line, we need either 2 points or we need 1 point and 1 slope. So but easy way is to, we can plot by Q line. So Q line is y is equal to Q over Q minus 1 x minus xf over Q minus 1. So what you can do is, you can put any value of x. We know the Q value. This is 0.389. 0.389. 0.389. This is 0.6. So you can put any value of x from 0 to 1. So let's say if I substitute value x here, x I'm substitute 0.5. So if I substitute, calculate, I will get y 0.66. So it means we got another point. So what you can do is, like, so if you like, I can take and let's say x 0.3, y come out to be 0.79. So any value you can put between 0 to 1 of x. So let's say this value. So x at 0.5, go up, up, up. So 0.5, y is 0.6. This is 0.6. This is 0.65, most probably, and 0.5. So this is 0.6, sorry. This is 0.65. So 66 slightly above like this. So your point will be here. So this point is 0.5 and 0.66. The coordinate of this point. Let's say you have 0.7, 0.3. So you have 0.3, x is 0.3, and you have 0.79. This is 0.3, 0.79. So all points are in a line. See? So you need only 2 points. So no need to worry. So you need only 2 points. So point is correct, 0.3, yeah, 0.79. So you all points are in a maybe this 0.7, but there is no proper scale. So once you plot, you have a proper scale. So see, whether you plot by 0.6 at 0.3, you got 0.79. This is point. So once you have 0.5, you got 0.66. I don't have in between scales, that's why maybe slightly, I don't know whether this is 0.79 exact or not. So this is how we can draw the Q line. We just need to take the Q line. All information is known. Psi in this problem we get from this question. This is given from the problem, not there is no such question, but this is only based on this problem. And once we get the psi, we can get the Q. We substitute the value of Q over here. We get the value, and then we can substitute any value of x. We got, with respect to that x, we got y. We get any value of x, we substitute, and we can get the y. Any one value. So choose only one. No need to choose two. Okay. So 1 point is here. So that's how we can plot the Q line. So once you plot the Q line, then you need to record this value. Then you need to record this value. So this is called, so what we can do is, so we can record this value in order to find R minimum. Once you draw the Q line, we have to record this value. Where your Q line bisects the equilibrium curve. So this is your y prime, and this is your x prime. So your y prime and this is your x prime. So once you know, then we can apply equation to get the values of so once you got this, then we have equation R minimum equal to xt minus y prime minus x prime. Let me make sure. So you got one point. So we got the y prime. So let's say the y prime value is it looks 0.68. So xd is 0.95. This is 0.68. And the bottom one is 0.46. So I have the exact value actually 0.684, 0.465 minus 0.684 over 0.684 minus 0.465. So if you calculate this one, it comes out to be 1.22. So this is how we can calculate R minimum. For R minimum, you need to draw, first we draw the equilibrium curve, then we need to draw a Q line. Once we draw a Q line, then we can, so how we can draw the Q line? You can just take the equation of Q line. This value is already known. This is 0.6 because it's XY line. So another point you can just calculate either by this way or by this way, and then you can find the R minimum. So this is how we can calculate the R minimum. The third part is we need to find actual N. How to find actual N? So again, we need to draw, make sure your line is perfect. Okay, it will reflect your answer. Again, we need to label, this is xt, this is your xf, this is your xb. So what we need to do is, so you see in this problem, R is given in terms of R minimum. So we have already calculated R minimum 1.22. So we have already calculated R minimum is 1.22. So what we can do is we can calculate R. R is equal to 1.22 multiplied by 1.3. It comes out to be 1.59. So once you get the R, then you need to find xt over R plus 1. So this will comes out to be xd, R is 1.59, xd is 0.95, it gives you 0.36. But again, before going to this step, we need to draw, we have already drawn the Q, the R minimum over that page. So we can, let's say we have x is equal to 0.3 and y, it comes out to be 0.79. So we need to draw first the Q line. So 0.3 and 0.79. So we got only, see, I base only 1 point because the other point we already have. So we can draw a Q line. So we got the Q line. Now we got xd over R plus 1. Xd R plus 1 is the intercept of a stripping line, of a rectifying line. So this will be 0.366. So it will be here. So 0.366. So this is the point. So what we need to do is we need to draw a line from xd until xd over R plus 1. And after that, we need to do is we need to get the stripping line. Okay, then we need to draw the stages. So this is how we can calculate the number of stages. So 1 horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal. So once you see this point, the trisection point of Q line, rectifying line and stripping line, rectifying line, Q line, stripping line, this point, you have to go, if you cross, you have to go down. So then go to the stripping line. Horizontal up to equilibrium curve, vertical up to stripping line now. So more or less we are getting almost XB. So let's see how many stages we got. So these are the number of stages. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12.2 something. So we got N 12.2. So see, this is how we can solve the problem. One thing so we just need to draw the steps I have already told you in my previous lecture. We just need to draw the rectifying line by this intercept. Q line first, then rectifying line, then stripping line, then we can draw the stages. I forgot to tell you one thing here. This point where the Q line bisects the equilibrium curve, this point is called pinch point. So any minimum condition, like if you want to find boil-up ratio, minimum boil-up ratio, or minimum flux ratio, you have to find the pinch point. So pinch point is where the Q line bisects the equilibrium curve. So like in this case, this is the pinch point. Okay. So at pinch point, you see, if you draw a line, the rectifying line, you cannot get the number of stages. You cannot go to the stripping section. So it shows you will have infinite number of stages. So this is how we can find. So the another part, this is the part C. So the next part is part D, feed location. The field location I told you where this trisection point is there. Under which stage the trisection point? This is under 6. See, 1, 2, 3, 4, 5, 6. So this under 6, this trisection point. So this is 6. So it means the field location is 6 stage. So let's see how to find minimum boil-up ratio. The boil-up ratio. We can also find minimum boil-up ratio. So boil-up ratio is you need to draw a line from the pinch point. This is the pinch point. From the pinch